All right, in this lesson 2.5, we are talking about using scatter plots to analyze patterns, determine regression lines and correlation coefficients, and to make predictions. Graphs for real-world situations rarely form a line, but can sometimes have a pattern that can be modeled with a linear function. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. The correlation or relationship can be seen by how close the data falls along the line and how closely. Now we also use what's called an R value when we describe the correlation, and the R value is between -1 and +1. Now, a negative correlation would be probably a real strong negative correlation. If we drew a line, the points would all be very close to the line. We would say that this is probably like a -1 if we were going to give it an R value. A negative correlation in which the points aren't as close would be a weak negative correlation, and that might be maybe a -0.5 or somewhere in there as far as the R value. Now, if we really can't figure out if the points are falling or increasing, if there's really no correlation, we would say that it has an R value of 0. And if we could draw a line and it would have like a positive slope, we would say that this has a weak positive correlation, probably around 0.5. And if we drew a line through this set of data, we see that the points are fairly close. We would say that that has a strong positive correlation, probably with a R value of 1 or close to that. Now, in this example, it says the table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot, and how would you describe the correlation? Well, a scatter plot simply is just where we graph the points. So at the average temperature of 61, the electricity bill is 150, so we plot 61, 150, so over 61, up 150, and the point is plotted. So to make the scatter plot, simply you plot those points, and we can describe the correlation. If we drew a line here, we see that these points are all fairly close to that line, so we would say that they have a strong correlation, and as the average temperature is increasing, the bill is also increasing, so we would say it's a positive correlation. So strong positive, probably an R value of close to +1. And after that, we can use the graph to predict. It says, what would you expect to pay for electricity if the average temperature was 70 degrees? Well, we look over here to 70 degrees, and so it would be somewhere in here, probably around $190, somewhere in here. And here we've plotted some points here. These are the number of hours online compared to the test scores. And we see that if we draw a line, those points are fairly close to the line. We can definitely see that it is a decreasing. So it would be a negative correlation here. That line would be decreasing. And so we would say probably a strong negative correlation, maybe around a -0.8. A trend line is a line that approximates the relationship between the variables of a scatter plot. A trend line can be used to make predictions. The most accurate trend line is called the line of best fit, or it's also called the regression line. And in Algebra 2, to write a regression line, we sketch a line. We estimate where it would be. So to do that, what we want to do is choose a couple of points and draw a line through it. Now, there isn't a right answer, but you want to have the line so that you have about as many points above as you do below. So if I go through these 2 points right here, I have 1, 2, 3 below, 1, 2, 3, 4, 5, 6 above. So that's probably not the best 2 points to pick. So let me just move this around a little bit, and let's go through these 2 points instead. So I have 1, 2, 3, 4 above, 1, 2, 3, 4, 5 below. Those are probably better points. So we have about as many points above as below. So now let's write down the coordinates of those points. We have 1, 2, and 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 7, 7. And so we choose 2 points, sketch a line. We did that. Now we find the slope between the 2 points using the slope formula. That is y2 minus y1 over x2 minus x1. And so we'll find the slope, and then 7 minus 1, so we have 5 over 6. So 5, 6, that's a positive slope. Our line is increasing, so that's good. Next, we're going to use the point slope formula. So that's y minus y sub 1 equals m times x minus x sub 1 to write the equation. And we'll just choose one of the points, and we will use our slope. So y minus 2 equals m, which is 5, 6, times x minus 1. And we will simplify that. And these often tend to be a little bit messy. And remember, we have to distribute the 5, 6 through. And then now we add 2 to both sides. So your final equation is y equals 5, 6x. And remember, when you're working with fractions, if you're struggling with it, you can use your calculator. Use the fraction key. So 2 minus 5, 6 would be 1 and 1/6. Now, when we look at our equation, we want to see if it matches the line. So for example, we said 5, 6, that looks like a reasonable slope, it's positive. And in 1 and 1/6 is the y-intercept. Well, look at where the y-intercept, my y-intercept looks like it's just under 1, so it's not very far off from 1 and 1/6. So that would be reasonable, a reasonable answer. So here's another example. It says you research the average cost of whole milk for several recent years to look at trends. The table shows your data. Write the equation for the line of best fit. How accurate is your line of best fit? So the first thing that you want to do here is plot the points. Now, when you have the years here, we don't put the years down on the x-axis. We have our starting years, 1998. We're actually going to call that 0. This is 2 years later, so this would be 2. This would be 4 years later. This would be 6 years later than 1998, and 8 years later, and 10 years later. So we will put the years on the y-axis. And so 0 to 65, plot that point, and then go over 2 up to 289. These are quite close. 4 will be at $3. 6 will be at 301, slightly, just a hair above. 8 will be at 320, and 10 at 377. Now those points are almost in a line, so it's not going to be really fussy which 2 that I pick. So we'll just kind of draw a line. We'll go maybe through the first and through the first and through, let's see here. We'll hit the first one and then the fourth one maybe. That should be pretty close. So those points, the first one is at 0 to 65. The fourth one over is at 6, 301. So now we have our points. We are going to find the slope. So we'll subtract the y's. And then in the denominator, we'll subtract the x's. So we have 301 minus 265, and that gives us 0.36 divided by 6, which gives us 0.06 for a slope. So that's 6/100. So we are barely increasing here. Now we'll choose a point. So we have y minus, and we're going to use the point slope formula. So y minus y1 equals 0.06 times x minus 0. So y minus 265 equals 0.06x minus 0 times 0.06 is 0. And then lastly, we'll get the y by itself, so put it in slope-intercept form. So we have 0.06x plus 265, and that is the y-intercept, 265. And so then it says, based on your linear model, how much would you expect to pay for a gallon of whole milk in 2020? And so we can figure out how many years later is 2020. So that would be 22 years later. And we could substitute in 22 for the x and get what the cost of milk would be based on that equation. So 0.06 times 22 and then plus 265. And that's it for this lesson. Let me know if you have questions.